Okay, for number 5, it says your calculator showed an R value that is close to 1. Remember, we have 0.91, which is 91%. 91% accurate. What does an R value close to 1 indicate? Okay, it means that well, I'm going to let you guys answer that. What does an R value close to -1 indicate? What does an R value close to 0 indicate? All right, so I'm going to go ahead and draw this out for you, or make an explanation here. If this right here is 1, if this is a number line and I expanded it, and this is -1, and right in the middle, I'm going to say it's right there, 0, is 0, okay? So the closer that your R value is to 1, the more accurate it is, okay? The more of a correlation there is. It's going to be a positive correlation. Okay? If it's 0, that means there's no correlation. I'm just going to write core for short, okay? But that is correlation. If it's -1, it's going to be a negative correlation. And so if it's anywhere close to here or here, this here is accurate. This is 100% accurate. This down here would be 100%, not inaccurate, but accurate as well. And in the middle, 0, 0 correlation is 0% accurate. Okay, here's an example. If we have a line going this way, and that's positive, we're going to have a positive correlation. Okay, now if the dots are right on there, or right on the line, the R value would equal 1. Okay, now the other one, the one that we graphed, it was 91%. So, we had some that were kind of off. That would be about 91%. So an example of a positive correlation is as the temperature goes up, the number of ice creams are sold. Okay? As the temperature goes up, so do the number of ice creams. That would be a positive correlation. Okay? Now, a negative correlation, again, I'll use temperature, but this time I'm going to use hot chocolate instead of ice cream. So as the temperature goes up, actually, let's go backwards. As the temperature goes down, people are going to buy more hot chocolate. Okay? And as the temperature is going upwards, so for example, if this was 10 degrees, 20 degrees, okay, over here I'm going to say 90 degrees, okay, when it's 90 degrees, not very many people are going to buy hot chocolate, okay? So when it's 10 degrees, lots of people are going to buy hot chocolate, or more people will anyways, okay? And as the temperature gets warmer, less people will buy hot chocolate. And this would be a negative correlation. And if they're red on the dots, if they're red on the line, it's super accurate, it would be -1. Okay, but obviously the amount of hot chocolates bought from the temperature is not always 100% accurate. Okay, most of the time, or oftentimes it's 90% accurate, 80%. So I'm going to make some points that will make this graph around 80%. Now, one last graph here. If this is my best fit line, okay, and again, I'm going to say temperature here. And over here, I'm going to say hamburgers. Is there any correlation between temperature and hamburgers? Okay, I'll eat a hamburger anytime. It could be 5 degrees outside. I don't care. I'll eat a hamburger. It could be 100 degrees outside. Again, I don't care. I'll eat a hamburger. Hamburgers are delicious. Okay, so when there's no correlation, you've got dots all over the place. This R value would be closer to 0. Okay, so let's go ahead and go back and answer the questions in our book. Okay, your calculator showed an R value that is close to 1. What does that R value close to 1 indicate? Well, it's going to be a positive because it's 1. If it's 1, it's going to be positive. So it's going to be a strong positive correlation. Okay. Next question says, what does what does an R value close to 1 indicate? Strong positive correlation. What does an R value close to -1 indicate? That's going to be again, because it's close to -1, it's going to be a strong, but instead of positive, it will be negative. Correlation. Go ahead and label this better. This one here is when R equals 1. Have a strong correlation. This is when R equals -1. Strong negative correlation. And remember, if it's close to 0, so let's put R equals when R is close to 0, there's no correlation. So the closer it gets to 0, the more there is no correlation. Okay. So let's go ahead and look at number 6. It says match the R values with their graphs. Here are the possible R values. They give us one here, another one, and another one. So looking at this, let's say we have a positive correlation, a positive, and a negative. So which one of these is negative? Okay, remember, as you're reading a book, we go from left to right. Okay, so just like you're reading, we go from left to right. So from left to right, we are going up. That's a positive. Again, left to right, we're going down. That would be negative. And on this one, going left to right, we're going up. So again, positive. So this one here is the only one that is negative. So I would say that this R here goes with this graph. R equals -0.6 would go with this one. So I'm going to go ahead and write that in. R, that's a terrible R. R equals negative 0.60. Okay, so now the other two are positive. Okay, I'm going to change my color here. These two here are positive. Okay, so if you're thinking about how I think about this is like 33%. So this one's 33% accurate. This one's 87% accurate. Looking at these two, which line would be more accurate? The 80. So this one, looking at these two, this one here, this line is more accurate. So I would say because 87 is closer to 1 than 0.33, I would say this R goes with this one. So R equals 0.87. Okay, and then this one, it does have a correlation. It is positive, but it's not very strong. These are pretty loose. Over here, you can tell that these ones here are a lot more tighter to the line. This one over here, it's pretty loosey-goosey here. Okay, this one's loose, not very accurate. And 33% is not very accurate. So I'm going to go with R equals 0.33. All right, let's go ahead and move on to question number 7. It says use the trend line equation y equals 0.35x minus 14 to answer the following questions. Find a prediction for the shoe size of a boy who is 67 inches tall. Okay, so we know that y is going to be the shoe size, and we know that x is the boy's height. So to write this equation, we're going to go ahead and write y equals 0.35x minus 14. Okay. So we know that y is the shoe size, and we know that x is the height, and we're trying to find the shoe size. So I'm going to go ahead and instead of y, I'm going to write shoe size equals 0.35, and instead of x, which is height, I'm going to write his height in, which is 67 minus 14. Okay, so first thing I need to do is multiply these two together. So we have 0.35 times 67. I'll give you guys a second to calculate that. And then you can join me for the final video.